Hello, everyone. Welcome to the monthly Azure Cache for Redis community stand-up. I'm a senior program manager on the team, and Shruti is my colleague. Okay,
Hello,
so Shruti, you're going to give a quick introduction?
no, I'm one of the product managers for Azure Cache for Redis as well, and Catherine and I work very closely on a lot of things. But yeah, thanks for joining us, and over to you, Catherine.
Sure. Yeah, so again, welcome. If you have any questions to us, again, reach out at azurecache-pm@microsoft.com. This is a monitored channel, and me and my colleagues are taking rotation to answer your questions. We'll do our best to assist you for your success. Okay, so today we are going to take a quick look into what is Azure Cache for Redis in case you are new and curious about our service. And then we will focus on the developer experience, starting with .NET, and we will talk about other languages in the future series. So here's an introduction to Azure Cache for Redis. Redis software itself is an open source in-memory key value store. Redis Inc. maintains an enterprise version of this software. So we have both the OSS version and the enterprise version. On Azure, we have a first-party partnership with Redis Inc. to provide a fully managed cache experience on Azure. So this means Azure Cache for Redis is just the same as any other first-party hosted Azure services. It's performant and scalable, cost-effective, it's secure, and it has seamless integrations such as the AAD integration, storage integration, to allow passwordless authentication, service-to-service authentication through managed identity. If you are interested in, please refer to a previous video Shruti did. Now, you may wonder, what can I do with Redis Cache or Azure Cache for Redis? The first scenario is a distributed cache. This means if my application calls into a database or calls into any web API dependencies to generate response to fetch data, I may want to just store the data in a fast accessing location, such as a cache. So I don't have to call into the database or the web service every time I need the same copy of data. This is when distributed caching come into play. Like traditionally, everything's stored in memory on the local server, but then in cloud environment, you really want to enable the scalability and resiliency by decoupling caching from your web server. So when you scale in and out, cache data is still there. And then another popular scenario is datastore. So suppose if you have a shopping web application, there are user-related profile data, and there can be shopping cart data that you don't have to commit immediately into database because everything's still changing. Cache is a very good place to save this type of volatile data. And then for large scale applications like fraud detection, stock market, where data needs to be streamed real time, and we may be looking at like hundreds of thousands QPS, Redis Cache is a good place to hold those data events. And then last but not least, in the microservices scenarios, because you want to decouple the front end and the back end applications, so each operate individually, you will need a message broker for holding the messaging communicated between the microservices. So cache can only be used in that way.
Cool. That's very versatile usage. Like I can see it being useful in various scenarios for myself. Like there's various data structures as well that Redis supports and makes your stream processing and pub sub easy to accomplish. and you don't have to introduce multiple products in your application. Redis can just take care of most of your requirements there. That's the Catherine.
Yeah, exactly like Shruti said. So I recently heard a lot of customers asking about how to keep cache and the backend data store consistent. Shruti, have you heard any of these asks?
Oh yeah, we get to hear about this all the time. Like especially if you're using a cache with your database to accelerate your database, then it becomes the biggest concern is how do I keep my cache and my database in sync, and how do I make sure that my clients or my users always get the refreshed data or the fresh set of data. So yes, this is a very valid concern that customers using cache and databases have.
Yeah, I mean it's really like a bummer if you want faster access to from cache, but then the data ended up to be outdated, right? So that's why we're having this slide to explain this a little bit because it's such a common concern from our customers. So there are well-established algorithms and practices for keeping your cache consistent with the backend data store. So these are all for the cache-side scenario. So suppose you do have a backend persistent data store, and then you put a cache beside it to accelerate the performance for some repeated or some slow queries. What if the backend data store gets updated? So the first cache invalidating scenario means every time you update a record in the persistent data store, you just delete, like remove the cache value that's in cache. So next time, if the application tries to read from cache first, it will be cache miss. So it will read from the database, and then it will update the record in cache. So these are the application level algorithms you have to implement, but it's very repeatable and very straightforward. So because every time invalidating cache and writing into cache may take some time, we want our application to be even more performant. That's where write through and write behind comes into play. Write through means the application updates the cache directly. So the cache always hosts the latest updated copy of the data. And then it will write to the data store synchronously at the same time to make sure every time a record in cache gets updated, the backend data store also gets updated. And meanwhile, other clients can read in the cache. And to scale this even further, we can make the write between cache to persistent data store to be async. So we shipped the Azure function support recently that allows an event to be triggered based on a Redis cache key space, and that function can execute to update the persistent data store. We also have a previous video in July on the community call to talk about this. Our colleague Kyle did the video, so if you are interested, please go to take a look. Now, all these algorithms sounds very, even though they're repeatable, but it seems like I have to write a lot of code for it, right? So that's why we started building some experience in the developer client libraries and tools to make sure the right level of abstractions are provided. Ideally, as a user, I just want to say, like, this is my function, this is the output, and I want the output to be cached. Honestly, I don't care about how it read into the cache or how the cache keeps consistent with the backend data store. So the first improvement we did is in the .NET 8 public preview, we shipped the IOutputCache Redis implementation. So this is pretty exciting because OutputCache has existed for a while, and in ASP.NET Core is available since version 7, but we did not have a reliable and performant Redis implementation. There are performance issues with like purge and like memory allocations and so on. So in .NET 8, we did a bunch of improvement targeting to the memory allocations, targeting to the performance. So you can use Redis Cache reliably to cache your web response output. Here is an overview of a demo application that we will be looking at. But basically, I have a web app hosting ASP.NET Core, and it calls into Azure Open AI. Yeah, it's fancy, something intelligent to generate images. And for the image it generates, put the output into cache. This is to make sure my application runs efficiently.
With that pattern, we'll actually be able to reduce the calls to OpenAI here, Catherine?
Yeah, definitely. So when my web app process the request, part of it is calling into OpenAI, which
Right.
is an external dependency, right? And the network call, also the latency on the OpenAI side to use the model generating the output. So by putting it into cache, we save the cost for the web server, like the CPU memory resource, to do all this work generating the output on the web app side, and also reducing the number of calls into OpenAI. So if you are looking to like save your quota or looking into the reducing the dependencies delay, this will be a very good solution.
Got it. That makes sense.
Yeah, and Shruti, like we talked about earlier, like the cache could potentially also be in the web app server, right? But then we wanted to decouple it from the in-memory. So if the web app scales, say like I have 3 copies of the web app, all 3 copies will have access to the cache, versus if it's stored in memory, only one server instance will have the cached entries, and then the other servers will still be doing the triple work to repeat the previous queries and dependencies.
Got it. And then it also, I guess, it also adds in a layer of resilience as well, because if the web app nodes fail over or anything, the data doesn't get lost. If it's in memory data store, then it will get lost. But with Azure Cache for Redis, your session store information will persist even if the nodes reboot. Is that right?
Yeah, exactly. So that's a very good point. Even for resiliency, you don't want your data to be lost. So putting it in cache is a very good option. Actually, with the highest tier, we have 5.9 SLA. So that's very reliable and ready for your production usage.
Got it.
Okay, cool. So let's jump into the code. So firstly, I guess everyone might be curious about the Azure Open AI service. So let's take a quick tour. So Azure Open AI service is the hosted Open AI service with a few models like GPT-3.5, GPT-4, and DALL-E, and other models available. It's hosted in Azure, and so like you have access to for your developing your applications, and it can also integrate well with other Azure services. This is the Azure OpenAI portal, so I applied for the private preview access. You can also do so if you're interested. Go to the Azure OpenAI Studio. This is the playground where developers interact with OpenAI to fine-tune the models or to test getting the developer APIs. So in the models section, you can see what are the models available. So we have the chat model, GPT. We have the embeddings model, and there's also the like image picture generation model. In my case, I have like the GPT-3 model deployed. Yeah, but then like for the sake of this demo, we are using the DALL-E, which is an image generation model. It's similar to GPT. I think it takes your like a human language as input, so you can ask for it like, please draw me an alien in, let's say, who's my favorite artist, let's say in Dali style. And now you see an image is being generated on the fly and is taking the input as like it reads the human language. And well, here's a little nice picture generated, very surrealistic. So on the portal here, in the view code section, you get all the developer access. If you need to know the endpoint, the key, here the example is in Python library, but REST API is also available. And actually, that's where I got my information to write my code for generating the image. So this is Visual Studio 2022 preview version, and it works well with the .NET 8 public preview. I installed the public preview 6, so I have access to the latest output cache with the Redis implementation. So this is my web applications business logic. It's just using HTTP client for making the REST API calls. And yeah, you can see it's a lot of code. Basically, I'm setting the headers and setting up the endpoints authentication to call into the Azure Open AI service. So it can take a prompt and generate the image for me. And in my program.cs, I did some initialization code and defined different endpoints so I can show you what it looks like with cache and without cache. So if we go to the deployed version of this web application, let's start with no cache. So this is my OpenAI art gallery. And let's say a bunny in cartoon style. Let's do something cute this time. Let me double check if my endpoint no cache. Okay. Actually, let me refresh this web app. Cool. Here's my OpenAI art gallery. Then let's just do an alien in Bengal style this time. You see the web app is loading and it's taking a while to like call into OpenAI and for the model to generate a picture. Yeah, actually it's pretty fast to generate such a picture ad hoc already. But for me, it's still taking a few seconds. And if I have like multiple users here waiting for similar result, probably I can just share the same output, right?
Mm-hmm.
So because it's not cached, next time like I refresh this, it will again taking the time to call into OpenAI and generate me another picture. So if that's the desired behavior, like you don't care about taking a few seconds, but you do want a new picture every time, that's actually fine. But in the case if you want to save the cost and reuse some of the previously generated pictures, here's how to do it. So in the program.cs, you can set the output cache. It only takes a few lines to initiate. So I added the output cache service and added the Redis cache implementation. Mm-hmm. And then I make sure I use the cache in the initialization code program.cs. And then in the other endpoint, I can set up a cached endpoint, like everything calling into this endpoint will be cached. All I had to do was to say .cache output bracket. That's it. I didn't have to write any code to interact with Redis Cache directly, which is the beauty of this abstraction. So the previous call, I didn't say cache output, so it will call into the API, generate new pictures every time. Now, if I cache the output, I should be able to reuse the same picture, and the web page will load like a lot faster.
That is super cool, Catherine. Can you show us how quick it looks now with the cached output?
Sure, sure. Somehow my browser is a little bit slow today, but let me see if I need to restart. Okay, and then if I say cache the output, let's say I want a French garden. It's taking some time to call into the API, and here's a picture of a French style garden generated. And now if I say like refresh, you'll see
So
it
it took longer the
stays.
first time because it was not present in the cache and you had to go to the API and then fetch the image, right?
Exactly. Yeah,
Okay.
it's always the first time it's a little bit slower, but then
Mhm.
the subsequent calls will be faster because it's cached.
Cached. Makes sense.
So you'll see if I refresh the browser or if I'm pressing the F5 here on my computer to make sure it's actually refreshed, and you'll see the same picture, and it doesn't have the latency.
Mhm.
And just a few things to call out. So using the cache output will get your default cache profile and settings. There are a few other ways to call it with a simplified programming syntax. For example, the output cache tag annotation. And also in both cases, you can define your custom attribute. For example, how long you want the output to be cached. In this case, it's in 15 seconds. And then there are other attributes such as like in which condition you want to cache it or not caching it. Like if the output is null, for example, then or in the error conditions, you won't want to cache it, right? So those are all the attributes you can define to overwrite the default profile. Okay. And now we'll look into another improvement we were doing in .NET. Um, the IDistributed cache. So distributed caching basically means maybe there's a backend data store and I want to cache the actual data returned from calling into the data store, or like some web API, but then different from the web output caching where it caches the entire web page content. This is caching the data I needed, and the data can be used for business logic, further computations, and so on. So we used to have to write a lot of code for calling into the distributed cache. So I'll show you one example. This is a previous demo I wrote, and you'll see like how many lines of code it is just to add an item into the shopping cart. And then you may have noticed like in multiple places I had to call the convert data to do the object serialization. And then I have to check if things are like present in the cache. If not, I'll have to go back to look into the data store and then get it again. So this code is really inefficient, right?
Yeah, it is a lot of lines and a lot of repeatable code for sure. Yeah.
Yeah. So we are looking into the improvement, and for now, we have a sample prototype for just wrapping on top of the distributed cache library, but then reducing the number of code developers have to write by abstracting away all the data or the cache and the data related costs. So for example, if I know the algorithm is to check into cache, if not, then go into the data store and then refresh the cache, all those can be automated, right? We don't have to ask everyone to write it again. Also, the object serialization code, it would be nice if the caching library can just take object and it can serialize using the best reliable library or based on user choice to handle object. So we had a blog post talking about this improvement. It's available in the .NET blog. Let me see, my browser is slow. Yeah, but improvements to the caching abstraction in ASP.NET Core. And it contains some sample code and walks through how this is done. So going back to my Visual Studio, I'll show you. So it's all available on GitHub. We will share the link later. But then in the distributed cache extension, this is the one file you have to copy to your project. And this file contains multiple libraries, like implementations for, multiple method in implementation for get async. It takes like the function in both sync and async ways, and you can also optionally pass in parameters from the state. So now this is my weather code. So remember we were seeing like a lot of lines of code for getting something from cache and then refreshing cache. So now with the get async library, all I have to do is to write these few lines of code. So this is the business logic in case if not in cache, how I get my data, and that's it. I don't have to write any object serialization. I don't have to set up the boilerplates for like reading, writing into cache, keeping the data store consistent, and so on.
Wow, that's just like one line of code. Is that it? And probably you'd have to initialize the cache as well, right? And that's it.
Yeah, correct. That's a good point. Initialization. So all I had to do was in program.cs, I add the initialization for the stack exchange Redis flavor of the distributed cache, and I can take advantage of the dependencies injection to get the cache object and then call into its extension method, the get async. In this case, I just pass in the function for getting the weather prediction, and yeah, that's it. So
Wow, that this is really
we can
awesome,
just
Catherine.
quickly.
Yeah, developers can just focus on their
Yeah,
business logic without having to worry about the boilerplate code and the serialization and all those complexities. This is a great improvement for sure.
yeah, exactly. Especially if you are getting started using cache, right? So you may not want to spend like additional effort writing this code and like testing, and could be manual mistakes. So if you are just looking into something quick, you want to use cache like right away, this is really good. And of course, if you are the advanced users and knowing Stack Exchange, the Redis library really well, doing those fancy scenarios, you can still do it. So this is the weather forecast generated. And now if I say like refresh, it will be the same data, like nothing's changing. And one neat feature we have is the in the Azure Cache for Redis portal, there's a console. So if you want to view what's stored inside in your Redis cache, you can do so. So let's just say, get me the list of all the keys.
Just a side note,
The
folks, the keys command is kind of not recommended in production because it can impact your server. But now we're just doing a demo. It's okay to do the keys command, but just be mindful of running the keys command on your production workloads.
Yeah, that's a very good point.
Yeah.
So we are dev testing now. In production, of course, no. Like
Yep.
suppose you have hundreds of thousands of entries, you don't want all the keys to be listed.
Yeah.
Um, then let's take a peek into what's inside this cache entry. Copy, paste. So you see these are the data actually returned from my web, like my locally running web application. Okay. Is the vector similarity search scenario. So like we saw earlier in the OpenAI part, we have different models. In addition to the picture generation model, I mean, it's more widely used for the chat and search, like embeddings model. So scenarios are, suppose if you have a bunch of unstructured data, say the text for thousands of customer feedback, you may not want to read through them one by one. You may want some nice summarization to tell you what everyone's saying, and then some anomaly detections and some like search ranking capabilities. So how do we make sure we can look into the text data to do these operations? That's where the vector embedding vectors into play. So the model, like as part of OpenAI, can translate unstructured text into the vectors, so they have a number representation. And then by calculating how far or close are the vectors, like usually we use things like cosine similarity, you can do operations like a search, summarization. You can identify how similar or how different the two comments are, and so on. So this will help increase your work efficiency, productivity, and make sure all the analysis can be done at scale. We have a reference application for it. It's a web app calling OpenAI, and there are Cosmos DB and Redis Cache for saving the data and the vectors, and Azure function for processing. So the flow goes like you upload the data, say like thousands of text files for customer feedback into Cosmos DB. It will trigger the function to call OpenAI and translate all these into vectors embeddings, and this will be stored in Redis Cache. And then in turn, the web app will call the vector similarity search APIs to look into Redis Cache and get the result in summary. So here's the link to the app. Okay. And that's all we have.
Thank you, Catherine. Thank you for covering all those improvements. I can clearly see developers' lives improving with the reduced code that they have to do and easier integration with Redis Cache, and then using it as a distributed cache or an output cache, like storing caching the API outputs. That's great. Thank you for all the work that you've been doing for improving the developer experience here. Thank you, Catherine.
Yeah, and thank you for joining us today.
And thank you, folks. Thanks all.